All right, today we've got a fascinating cosmic detective story for you. We're looking at a galaxy that has, well, all the right stuff to be building stars like crazy, but for some reason, it's just not. It's hiding a really strange secret right at its heart.
So, meet our main character, Messier 58, or M58 for short. It's sitting out there about 68 million light years away in the constellation Virgo. And I mean, just look at it. It's a beautiful, picture-perfect spiral galaxy with these incredible sweeping arms. And this is where things get weird. M58 is absolutely packed with the raw materials, we're talking gas and dust, to make tons of new stars. But right in the center, where you'd expect things to be busiest, the star factory has been completely shut down. So the big question is, why? Okay, let's get properly introduced to our galaxy of the hour. M58 is a classic beauty, for sure, but it's that puzzling secret hiding inside that makes it so incredibly interesting. So here are the quick stats. M58 is a real heavyweight, a member of the giant Virgo galaxy cluster. It has a classic barred shape. And, yep, it's home to a supermassive black hole. But here's the crucial detail for our mystery. It has huge amounts of gas and dust. That's star fuel. In theory, this place should be a nonstop stellar nursery. So let's zoom in on what we might call the scene of the crime, the galaxy's strangely quiet center. Just like it says here, all the ingredients are on the shelf, but the kitchen is completely closed. These images really show you the paradox. On the left, you see the galaxy's outer arms, glowing with bright ultraviolet light. Those bright spots are the telltale signs of hot, young, newborn stars. It's a party out there. But then you look to the right, at the inner disk, and even though it's full of gas, it's just dark, eerily quiet. No new stars are being born. And researchers confirm this with some pretty clever chemistry. This quote from the study basically says that the light they're seeing from the core, it's just the gentle glow of old stars. There is absolutely no energetic fingerprint of new star formation. So yeah, the factory is officially 100% offline.
So, if it's not making stars, something has to be stopping it, right? And this brings us to our prime suspect, that supermassive black hole lurking right at the very center of M58.
And when we zoom in with radio telescopes, bingo, we find our culprit. Those white contours you see are mapping out a powerful jet of energy that's just blasting out from the galaxy's core. This isn't some quiet, sleeping black hole. This is an active galactic nucleus, an AGN. And that, right there, is our smoking gun.
So what exactly is an AGN? Well, it's what we call a supermassive black hole that's actively feeding. It's gobbling up gas and dust. But black holes are messy eaters. Not everything goes down quietly. A huge amount of that energy gets fired back out into the galaxy, and a lot of the time, it's in the form of these incredibly powerful jets. Okay, so we've got our suspect and a potential weapon. Now it's time to play detective and follow the clues left behind at the crime scene to see if we can really build a solid case against this black hole jet.
Our first clue is temperature. Data from the Gemini telescope shows this huge disk of gas in the center. But here's the kicker. This gas isn't cold and calm. It's been superheated, most likely by powerful shock waves ripping through it. And as we know, to form stars, you need cold gas, not hot gas.
Clue number 2 is all about motion. These colorful maps from the ALMA observatory show us the speed of the gas. And instead of things moving in a nice, orderly orbit, the mix of colors tells us the gas is being violently churned up. It's a total chaotic mess. It's like trying to build a sandcastle in a hurricane. It's just not going to happen. And just how violent are we talking? The turbulence in this gas was measured at up to 300 kilometers per second. That is just unbelievably fast. At those speeds, gravity, the one force you need to pull gas clouds together to form stars, is completely overwhelmed. It doesn't stand a chance. Our final clue is a chemical fingerprint. Data from the Spitzer Space Telescope analyzed the type of energy coming from the gas, and the signature it found screams shockwaves, like a sonic boom is constantly ripping through the area. It is definitively not the kind of glow you'd get from newborn stars, which pretty much rules out any other explanation. This simple comparison says it all. The gas in that inner disk is sitting at around 300 Kelvin. Meanwhile, out in the star-forming zones, it's a frigid 50 Kelvin, so it's 6 times hotter in the quiet zone. Way, way too hot for stars to get their start.
So, we've reviewed all the evidence. We have our suspect, we have the weapon, and we have a clear motive. Stop star formation. It's time for the verdict, and it reveals something really profound about how entire galaxies live and die.
You know, the mechanism is actually pretty simple to imagine. Think of the jet as a cosmic leaf blower. The galaxy's center has all these nice, neat piles of gas, like leaves, all ready to be compacted into stars. But this jet is just constantly on, blowing those piles apart, heating them up, and preventing them from ever settling down.
This whole process actually has a name in astrophysics: AGN feedback. It's this fundamental idea that the energy blasting out from a central black hole doesn't just disappear into space. No, it actively feeds back and influences its host galaxy, in this case, by shutting down star formation.
And the researchers agree. This isn't just about destruction. As they say here, it actually helps to regulate the galaxy's growth. By preventing the central regions from forming too many stars all at once, the black hole is basically acting like a thermostat, controlling the galaxy's evolution.
And if there was any doubt left, this data absolutely seals the deal. The energy radiating from all that hot gas is immense. But the energy coming from the black hole's X-rays, it's not nearly enough to account for all that heat. The only explanation is the raw kinetic force, the physical push of the jet itself. Case closed.
So why does this one case matter so much? Well, because M58 isn't some weird anomaly. It's a textbook example of this process. It's one of the clearest views we've ever had of a mechanism that scientists think is fundamental to how all massive galaxies, including our own, evolve over billions of years. And that leaves us with a final, really interesting thought. We usually think of black holes as agents of pure destruction, right? But if they're also acting as regulators, kind of pruning their galaxies and preventing them from growing out of control, are they also cosmic gardeners? Maybe their role in the universe isn't just to end things, but to create balance.